We'll begin our second unit looking at a brief review of grade 11 physics when we're talking about work. And as a reminder, we need to remember that the definition of work, which is a transfer of energy from one form to another. We should just briefly recall as well that when we're talking about work in our mathematical equations, we short form work with the symbol W, and that when we go to calculate work, it is force multiplied by some displacement d, and that is when we're on a flat level. If we're on an angle, that will be our applied force, Fa cos theta multiplied by some displacement d. Remember that this is our applied force. Our theta is the angle between the force and the displacement, and delta d clearly represents our displacement in this case. We remember as well that work is measured in joules. Which we short form with the capital letter J, and also that it is scalar, meaning that we do not need to worry about including any type of direction. We do have three conditions for work. These three conditions must be met for work to occur. First one is that we must have a constant force applied. The second one is if we have a force applied, the object that the force is being applied to must move. If any one of these two are not met, no work can be done. And three, the component of the force is in the direction of motion. So all three of these must occur for positive work to be done. If, however, 3 does not get done, if the component of the force is not in the direction of motion, say in the opposite direction, that is when we might have negative work occur. So let us now just go through a few quick examples. Let's say like a golf club exerting a force of 42.3 newtons on a golf ball over a distance of 2.52 meters. Let us determine how much work is done on the golf club. We are given in this question that our force is 42.3 newtons. And we are given a displacement of 2.5 meters. Let us calculate what the work is done on the golf club, or done by the golf club, I should say. So work, and we're assuming theta is 0 degrees, we're assuming this is just over a flat surface, so work is force multiplied by our displacement. So that will be 42.3 multiplied with 2.52. And if we were to calculate this, we see that we would get 106.596. If people lost marks on their assignments for the first 4 assignments, and I'm going to be a little bit more diligent about that here on out, for communication marks, I'm really looking to see if you have significant digits. And let us observe in this question. The force of 42.3 has 3 significant digits. The displacement of 2.52 has 3 significant digits. In this case, the lowest number of significant digits is 3. Therefore, our answer must also have 3 significant digits. So let's look at this. Rounding 106.596 actually becomes 107 joules. You'll notice in this answer, since there's a 0 in between 2 non-zero digits, 1 significant digit, 2 significant digits, 3 significant digits, and I have a proper unit of joules as well. I'm making sure that communication is done properly. Very quickly, side point as well. What's our units? You should realize that a joule is exactly the same as 1 Newton meter. And I know that this is a Newton meter because my force is measured in newtons, my displacement in meters, Newton meter. So 1 joule is equivalent to 1 Newton meter. But work we still just communicate in joules. Example 2, we lift a 6.52 kilogram turkey from the floor to the kitchen table that's 87.2 centimeters high. How much work have we done? Good question. Let us observe this. I see that my mass is 6.52 kilograms and that I have a height of 82.5 centimeters. Let's change this into our SI unit of meters by dividing by 100. So this is 0.825 meters. Let us now calculate how much work we do. Now remember, work is the transfer of energy. The change in energy in this question, or energy that we're looking at is, let me rephrase this, our energy in this case is gravitational. And gravitational energy is mass times g times h. So therefore, our work done will be 6.252 times 9.81 times that height of 0.825, because our force and our displacement are in the same direction. I always go with as many significant digits as possible. That is a 5. I really do need to hit up a Walmart to get a brand new marker, I think. So let us make sure of our answer in this case. Let's see significant digits. 3 significant digits. 3 significant digits. My answer must have 3 significant digits. So 1 significant digit, 2 significant digits. My last significant digit will be the 7. But let's look at rounding. My digit after it is a 6. So 52.8 joules is the work that's done lifting this turkey up to that height of 82.5 centimeters. Example 3. Not sure if it's appearing on my screen right now. It doesn't look like it. It seems like my computer has frozen. And I'm not entirely sure if it has frozen. On my screen right now, I'm getting a blank screen appearing. So what I will do, it might be appearing, I don't know. So what I will do is I will give the third and fourth example in a PDF format, and I will upload it to the website as well so that everybody can see how the question is done.